Hello everyone, my name is Mohammed Firdaus. So today I am going to present to you my analysis of the malware using basic static analysis. So now before I start analyzing the malware, it is important that I obtain some information about the malware itself. To obtain information about the malware, I will scan the file using an antivirus scanner. Antivirus scanner is used to identify suspicious code, analyze the file's behavior as well as to carry out pattern matching. The antivirus scanner that I'll be using is VirusTotal, which scans and analyzes suspicious files using different AV engines, and it can also generate a report. So I will now use the antivirus scanner, which is a VirusTotal. Select the malware file, open it and scan it, after which I will view the analysis. So as stated here, VirusTotal will detect this malware to be a Trojan, a set crack Trojan to be exact, to be precise. So next I'll move on to hashing. Hashing is a common way of fingerprinting a malware. It is unique and one-way function and is produced using a special tool or algorithm. Windows MD5. WinMD5 is the tool that I'll be using to generate the hash value for the malware in this case. So I'll open up the WinMD5 application, open up the malware file, and as you can see, this is the hash value of the malware, which is DD37 etc. all the way until AA. Now I will start analyzing the malware using the tools stated here, which is PID, PEView, Dependency Walker, and Bintex. So the first tool is PID. Malware authors often pack their malware. Why? Basically, they want to hide its true intentions or contents, and they want to make it harder for the malware examiner to analyze. PID can also be used to determine if the malware is packed or unpacked, and it can be used to determine the language used to write the malware. So I will now open up the malware using the PID application to see whether it's packed or unpacked, and to see the language used to write the malware. As you can see, the malware is unpacked because it is written in Boolean C++ language, which is a C and C++ programming environment for MS-DOS and Microsoft Windows. It was the successor to Turbo C++ and included a better debugger, which was called the Turbo Debugger, which was written in protected mode DOS. So now I want to gather more information about the malware. The first tool that I'll be using is PEView. PEView provides a fast way to view the structure and content of a file. The date and time in which the malware was created and compiled can also be determined. So I will show you now. I will open up the PEView application, open the malware file, under image anti-headers, image file header, time date stamp. As you can see, it states here that the malware was created in the future, which is absolutely ridiculous, but nonetheless, according to PEView, the malware was created on the 6th of April 2048 on the Monday 3:42 p.m. The next tool that I'll be using is Dependency Walker. Dependency Walker is a free utility that scans any 32-bit or 64-bit Windows module, for example, exe files, DLL files, etc. It also lists all the imported and exported functions. So I'll now open up the malware using the Dependency Walker tool, and it takes quite some time. Okay, there you go. And as you can see here, the malware imports 6 DLLs: ADVAPI32.dll, kernel32.dll, comctl32.dll, gdi32.dll, user32.dll, and oleaut32.dll. So I will first analyze the ADVAPI32.dll, and as you can see, this DLL imports some suspicious functions like req-close key, req-open-key, req-query-value, which basically means that this malware is trying to tamper with the Windows registries. For example, req-close key closes the handle to the specified registry key. Req-open key is a handle that opens the specified registry key, and req-query-value is used to retrieve the data and type for the specified value name that is associated with an open registry. Next, I'll look at kernel32.dll, and as you can see here, it imports some suspicious functions like create file, which basically means that it creates or opens a file or input-output device. It also returns a handle that can be used in order to access the file or device. Other suspicious functions will be to initialize critical section, which initializes a critical section object, and lock resource, which retrieves a pointer to the specified resource in the memory. Next, I'll look at comctl32.dll under kernel 32.dll. Some of the suspicious functions that this malware imports is get system info, which basically means it is trying to retrieve the information about the current system. Query performance counter, which retrieves the current value of the performance counter, and sleep, which suspends the execution of the current thread until the timeout interval elapses. Now for GDI32.dll, under ntdll.dll, some of the suspicious functions are anti-connect port, which indicates that the malware is trying to establish a connection with a specific port, and anti-register thread terminate port, which basically means that the malware executes the thread before terminating the port. So this tells us that the malware is trying to make a connection, possibly to the malware author or attacker. For the user32.dll, under powrprof.dll, some of the suspicious functions that it imports is set active power scheme, read power scheme, get active power scheme. So this tells us that the malware is trying to tamper with the power scheme in order to have complete control of the operating system. For example, get active power scheme basically means that it is trying to retrieve the index of the active power scheme in order to have control. Lastly, for OLEAUT32.dll, some of the suspicious functions is sys string len, which returns the length of a BTSR, and BTSR happens to be associated with Trojan, and as shown earlier in the video, VirusTotal has detected this malware to be a Trojan, so this is suspicious. The final tool that I'll be using is bintex. Bintex is used to extract useful strings and files available in any file. For example, APIs, which stands for Application Programming Interfaces. So I'll now open the malware using the bintex application, and as you can see, the malware imports many suspicious functions, and some of the suspicious functions is controls t win control, controls t control, which basically means that the malware might be trying to take control of the operating systems. There's many more. As you can see, installed successfully, your computer has been, yeah, I know. See, get local time, get the file size, locking resource, loading resources, writing files, yeah, destroying menus, creating pop-up menus, many more suspicious strings. For example, wait for inputs, wait message, which might indicate that the malware might be waiting for a message from the malware author or attacker possibly, and many more suspicious functions that it imports. So yeah. So yeah, basically this is what the malware is trying to this is what I have derived from the basic static analysis of the malware.